So, spherical geometry, we've got the formulas for arc length and area of the sector. These are the two that we'll be using quite a lot, particularly this arc length here. This is what we're going to be doing when we come to doing geometry around the world. Area shaded segment, what this is the two formulas. We've got the area of the sector and minus the area of the triangle. So what we're doing, if we're finding this shaded area, we're finding the whole area of the segment, and then we're subtracting this triangle. So the shaded area is what we're going to be left with. So going on to global geometry, latitude of the horizontal lines around the world. So when we talk about latitude, we compare it to the equator, which is north and south of the equator. So for example, we have in this picture here, our equator being 0 degrees latitude. We have this line here being 30 degrees north of the equator. So we say 30 degrees north in terms of latitude. This one here, it's 30 degrees south of the equator. And how the best way to look at this is in a 2D diagram. So we've got a 3D diagram there. Put it on a 2D diagram. So there's our equator straight across the line. We're going 30 degrees north of the equator, or 30 degrees south of the equator in this example. So the best way to do it is look at it as a 2D diagram. Longitude are the vertical lines around the world. These connect the north and south poles together. So if we look at this as terms of our north pole, our south pole's underneath on the other side. And what we're comparing to is the meridian line, or the prime meridian line. This is a line that on one side of the world is prime meridian, on the other side of the world is the date line. This line actually pretty much goes through London. So what we do is we compare it from degrees east or west of this line all the way around the world. So if we're going to look at that as a cutout, this is what we want to be trying to find. We want to be trying to find these segments in the world. So using the radius of the world to find these segments for latitude and these segments for longitude. So for example, in this case here, we're 40 degrees north on latitude because we're 40 degrees north of the equator. In this case, that's our prime meridian line here because it's 0 degrees. We are 60 degrees east of the prime meridian line, so that's where we get our segments from. If we're looking at calculating distances between the 2 points, we need to first off find the angle. So we need to use the latitude information and longitude information given. So for example, in this, our total angle for this segment is we've got 40 degrees north of the equator, 30 degrees south of the equator. What we would use in our calculations would be 70 degrees because we've got the 40 plus the 30. And we'll just use that formula that we've learned all the way back at the start for arc length. So you'd put that angle in here, and there is an example of a 2D diagram of arc length. Now what is the radius of Earth? Our radius is 6,400 kilometers. So that's what we'd use in terms of the R for our formula. So using the arc length formula to find distance, we need our degrees, we've got our radius, just plug it into the calculator. Hopefully that helps.